At the beginning of 1943, the war in Europe is being fought on two main fronts at once. In the East German forces are holding back the advance of Soviet troops, where the T-34 medium tank has broken through infantry defences several times at close range and reached the rear areas. In the West, the commands of Britain and the United States are preparing a landing in France, and the name of the future Operation Overlord appears more and more often in the documents. In Berlin, the Army Ordnance Office, Heereswaffenamt, writes down a simple requirement. An infantry soldier needs a light weapon that will allow him to stop a tank within the length of a single city street. To carry out this task, they bring in the Hugo Schneider AG plant in Leipzig, which is already working on military contracts and can quickly launch a new production line engineer. Heinrich Langweiler, who's used to working with mass-produced stamped parts, is put in charge of the design work. At the first meetings, representatives of the Heereswaffenamt set out the constraints. The weapon must be cheap, single-use, and understandable for a soldier who has completed only a short training course. In a separate line, they note that it is enough to keep the effective range within 30 metres, 98 feet, because in a city distances are rarely greater. On Langweiler's desk lie sketches and metal samples, next to them a piece of armour 80mm, 3.1 inches, thick, and a table of explosive compounds. The design team chooses the shaped charge principle, where a thin metal cone inside the warhead directs the energy of the explosion into a narrow jet. For the charge, they take a mixture based on TNT and RDX, with a mass of about 400 grams, and the calculations give penetration of up to 140mm, 5.5 inches, of homogeneous armour when striking at a right angle, so that the shooter can hold the weapon on the shoulder without a mount. They propose to vent part of the gases backwards through a nozzle, reducing recoil. This is how the layout of the future single-use anti-tank launcher Panzerfaust appears. The drawing shows a smooth tube, a large shaped charge head at the front, and an expansion at the rear for the gas outlet. And before we continue, let me know in the comments where you're listening from. It's always amazing to see how far these stories travel, and if you're enjoying this one, don't forget to subscribe and smash a like. The tube length is set at about 0.98 metres, 38.6 inches, and the total mass of the weapon is kept at 3.2 kilograms, 7.1 pounds, so that an infantryman can carry one or two tubes together with his rifle and gear. The body is planned to be made by stamping from ordinary steel, and the stabilizing fins are placed on the tail of the warhead so that they fold along the line of flight and open by themselves in the air. The first prototype receives the designation Faustpatron and is sent to the range near Schlieben. On flat ground they mark the 30-metre, 98-foot distance in white paint, and behind the line they set armour plates and metal shields taken from written-off vehicles. After the shot they find a neat crater on the plate and a narrow channel running through the entire thickness of the metal, which confirms the penetration calculations. Behind the shooter they measure the length of the dangerous hot gas zone. It is about 3 to 4 metres, 10 to 13 feet, and this distance is immediately included in the instructions. Separately, they resolve the issue of sights, because a complex scale requires long training and leads to errors under stress. Langweiler proposes a simple metal sight leaf with one large notch for 30 metres, inside which the target is visible. A low front post is fixed on the warhead, and when aiming the shooter raises the tube onto the shoulder, aligns the front post with the notch, and waits until the side of the tank completely fills the gap between the walls. The Heereswaffenamt representatives approve this option because it fits the task of a few steps and one shot. After the first firing test, the designers notice that any deviation in the mass of the warhead changes flight stability, and they introduce mandatory weighing of each warhead. The mounts of the stabilizing fins are reinforced so that opening in the air is uniform from batch to batch. The production department notes that all parts can be manufactured on the existing equipment, without installing complex new machines, which speeds up the start of production. The documents now use the series name Panzerfaust 30, which directly indicates the designed effective firing distance. When the first batches of the Panzerfaust are ready, a training company receives the crates and sets up classes in an empty house by a railway line. In every room, a line is drawn in chalk on the floor to show the boundary of the danger zone behind the nozzle, and every lesson begins with this step. The instructor shows the tube, explains the purpose of the shape charge warhead, demonstrates the sight leaf and the firing position from a window or doorway. Then the soldiers take turns practicing the full cycle, checking that the space behind is clear, lifting the weapon onto the shoulder, aligning the front post with the notch, firing, and leaving the room. After the training company had run the first batches of Panzerfaust 30 through drills in the empty house by the railway line, the same crates went further along the tracks. The shipping documents now listed 2 destinations at once: the Eastern Front and the cities where fighting against Soviet troops was underway, and the West, where advances by British and US forces were expected after the landing. At junction stations, the crates were unloaded into sealed local defence wagons and immediately assigned to specific blocks and buildings. An officer noted in the ledger which entrance received the tubes, which floor would cover the close sector, and where the reserve would be held. In cities behind the front line, the rooms overlooking intersections began to be prepared according to a single pattern. The lower floors were given to rifles and machine guns. The second floor was assigned to the single-use anti-tank launcher Panzerfaust 30, and the attic to longer-range shots. For the close sector, they used a working band of 25 to 35 metres, 82 to 115 feet, where the side of the tank filled almost the entire width of the window and did not require complex lead calculations. For the upper level, they gradually introduced the Panzerfaust 60 with an effective range of up to 60 metres, 197 feet, where the trajectory stayed above the roadway and debris. As in the training house, a line was marked on the floor in white paint beyond which people and equipment could not be placed, because the hot gas stream behind the tube occupied 3 to 4 metres, 10 to 13 feet. Before combat, the instructor took the teams out into an actual block and showed them the street through the eyes of the gunner, not only on a classroom diagram. He placed the soldier at the window, pointed out the spot where the side of the vehicle would appear in the opening at a speed of about 10 to 15 kilometers per hour, 6 to 9 miles per hour, and asked him to count out loud to the moment when the hull would close the gap between the buildings. At the neighbouring intersection, they marked the angle to the side with chalk, because when the trajectory deviated by 30 degrees, the shaped charge jet lost part of its penetration depth in armour tests. In the exercise cards for each building, they recorded the height of the windowsill, the distance to the expected firing point, and the position of the engine compartment for different types of armoured vehicles. On the Eastern Front, the first real uses came in cities where the streets had already been shattered by artillery, and T-34 medium tanks had reached the barricades. The T-34's frontal armour was sloped and up to 45mm, 1.8 inches, thick, so trained teams waited for the moment when the tank entered a turn with its side exposed to the window. For a side shot at 30 metres, 98 feet, they used the Panzerfaust 30, and a hit near the centre of the hull gave a clean channel through the plate and damage to the components behind it. Deeper inside the building, a reserve tube was kept in case the next vehicle showed its rear at an almost right angle in the same corridor. When British and US forces moved into the cities of Western Europe after Operation Overlord, the reports more and more often mentioned fighting against M4 Sherman medium tanks. The diagrams for the teams noted that the Sherman's frontal hull armour was about 50mm, 2.0 inches, thick, while the sides and rear were weaker and closer to vertical. In narrow streets, they built the same logic for the Sherman. A close Panzerfaust 30 hit against the side during a turn at 25 to 30 metres, 82 to 98 feet, and a longer Panzerfaust 60 shot at the rear on a straight section. After firing, the gunner moved to the next window or went up a floor so that his silhouette would not repeat in the same frame where return fire had already been directed. The response from the tank units came through changes in movement order and stronger escort. Infantry went ahead of the columns, passing the first windows and doors and clearing them with grenades and bursts of fire, and only then did the vehicles move up. Before intersections, drivers were instructed to pass the stretch without stopping and not linger in the centre, because a stationary target gave a Panzerfaust team a full side profile for 1 or 2 seconds. Tank instructions added the requirement, where possible, not to expose the side to 2 window levels at once, so turns were preferably made under a smoke screen or with heavy fire directed at the facades. As add-on armour skirts, sandbags and boxes appeared on the vehicles, new aim point techniques were introduced into the training materials. For the Panzerfaust 30, when firing at the side at 25 to 30 metres, 82 to 98 feet, the aim point was shifted closer to the lower edge of the plate, in the area between the road wheels and the armour line, where the protection remained solid and was not covered by additional structures. The instructions stated that the aim point should be taken 0.2 to 0.3 metres, 8 to 12 inches, below the geometric centre of the side so that the jet would go into clean metal without false layers. For a rear shot with the Panzerfaust 60 at 50 to 55 metres, 164 to 180 feet, they recommended aiming at the area above the engine compartment, where an exposed zone in terms of thickness remained even with add-on protection. The preparation of rooms for anti-tank weapons became a permanent part of the work of garrisons preparing for urban combat. Doors in such rooms were taken off their hinges so that the gas stream after the shot would go out into the stairwell and not be reflected back through a narrow opening. In the corner by the wall they kept a bucket of water, a box of sand and brushes, because glass and plaster fell to the floor after the first shot and interfered with further movement. On the wall near the window they hung a short reminder with drawings. Check the zone behind, lift the tube onto the shoulder, align the front sight with the notch of the sight leaf, fire, change position to the neighbouring window or another floor. On staff maps near the names Budapest, Cologne and Danzig they added notes about buildings where stocks of Panzerfaust 30 and Panzerfaust 60 were concentrated. In Budapest, the long boulevards allowed attics to be used for long-range shots at the rear of the first vehicle in the column, and there they more often recorded ranges of about 55 to 60 metres, 180 to 197 feet. In Cologne, rooms with deep windowsills gave the gunner an extra second to align the sight mark in low light, and this time was factored into the training schedule on the eve of fighting. In Danzig, the narrow streets along the waterfront exposed the tank's side at the moment it came out to the water, and this short interval was measured in paces and on the map, so that specific figures could be entered into the training cards of the teams. Over time, the combat reports noted more and more often that armoured columns of Soviet forces and British and US forces were changing their movement order because of the appearance of Panzerfaust 30 and Panzerfaust 60. Tanks entered the street not alone but under cover of riflemen, who moved along the sidewalk spread out along the facades. Before each intersection the infantry checked the first windows and basements, and only then were the vehicles brought forward. Separate instructions for the crews emphasised that turning without checking the openings gave a single-use launcher team an almost perfect side shot. New orders for tank units laid down specific figures for the speed at which to pass dangerous sections and what intervals to maintain. At intersections, it was recommended not to reduce speed below 12 to 18 km per hour, 7 to 11 miles per hour, in order to shorten the time during which the flat side profile was fully visible in the window. The distance between tanks was set at 15 to 20 metres, 49 to 66 feet, so that a knocked-out vehicle would not immediately block the entire column. The flank riflemen were tasked with keeping the second and third floors under constant observation, and not allowing a Panzerfaust team to calmly bring the front sight into the notch of the sight leaf. The supporting artillery also adapted and brought in smoke shells to cover the facades. Guns of 75mm, 2.95 inches, and 76.2mm, 3.00 inches, produced short smoke screens in front of buildings where positions with single-use anti-tank launchers were likely. As the tanks entered the sector, anti-aircraft mounts swept along the line of rooftops, stripping plaster and glass and making aiming more difficult. In the urban fighting instructions of the Allied forces, direct references to the Panzerfaust threat and to the need to work against windows in advance appeared more and more often. For German defence, Panzerfaust 30 and Panzerfaust 60 became the basis of tactics at certain bridges, squares, and fuel depots. On the approaches to bridges, they selected in advance the houses from which a tank's side would be exposed at the moment it moved onto the span, and several tubes were brought there for each stairwell. In narrow sections of streets where vehicles were forced to move in single file, the team marked on the wall with chalk the height at which the side of the tank passed opposite the window. On the evening before the battle, they repeated their stance with a training tube against these marks, so that in actual combat they would not waste time searching for the aiming line. Once the basic variants had been mastered, the design team returned to the longer-range Panzerfaust 100. The calculation set an initial velocity of about 60 meters per second, 197 feet per second, and a nominal range of up to 100 meters, 328 feet, so that in theory the gunner could engage a target at the next intersection. The warhead diameter remained around approximately 149mm, 5.9 inches, and the tube itself was lengthened slightly compared with the Panzerfaust 60. At the same time, the methodical instructions for urban combat still recommended practical distances of up to 60 meters, where the target was still clearly visible in the notch. By the end of 1944, the single-use anti-tank launcher had turned from the limited experience of a single company into a mass defensive weapon. In addition to the Hugo Schneider AG plant, other facilities were brought in, and the total number of Panzerfausts produced was now measured in millions of units. The tubes were bundled based on a mass of about 6 to 7 kilograms, 13 to 15 pounds, per unit, so that one man could carry 2 of them, plus a reserve of rifle ammunition. Transport documents listed not only the quantity, but also the specific area of deployment, so that the weapon would not be scattered along secondary sectors. Among the late users were Volkssturm units, where the ranks included older men and teenagers. For them, simplicity was especially important, so the Panzerfaust instructions were reduced to drawings and 4 key steps without complex terminology. Training used mock-ups where colour indicated the 3 to 4 metre, 10 to 13 foot zone behind the nozzle, and the flat side profile of the target at 30 and 60 metres, so that even an untrained person could see the geometry of the shot. In practice, this made it possible to quickly bring to an acceptable level people who had previously only held a hunting rifle, or had no military experience at all. At the end of the war, in the fighting for Berlin, the single-use anti-tank launcher appeared at almost every major intersection. Into the city came T-34 medium tanks and heavy IS-2 tanks with thicker armour, but at close range the shaped-charge Panzerfaust warhead still posed a serious threat. In short streets and courtyards where the distance shrank to 20 to 25 metres, 66 to 82 feet, the sight leaf and simple front post provided enough accuracy for side-hit reports from advancing Soviet troops included instructions to bypass certain blocks or suppress them with fire if multiple positions with single-use launchers had been observed there. After the end of hostilities, captured Panzerfausts were carefully examined by specialists from different countries. Soviet designers considered the German single-use anti-tank launcher as a starting point for their own handheld anti-tank systems, in which reusable and single-use rocket models would later appear. In Western armies, the idea of a light, simple and cheap weapon that one infantryman could carry and use, according to a clear procedure, also became established in future projects such as compact launchers for squad-level use. Technical reports separately noted the combination of shape-charge warhead, folding stabilizers, and rearward gas venting with which the German weapon solved the problem of close combat against tanks in the city. In the post-war years, individual examples of Panzerfaust 30, Panzerfaust 60, and Panzerfaust 100 ended up in museums, where they were displayed next to photographs of urban fighting. The exhibits often preserve the original inscriptions indicating range, danger zone, and simple steps for the gunner. Nearby lay training posters that showed without words the firing position at the window, the aiming line, and the sector behind the tube. For a visitor looking at these objects after the war, the combination of an ordinary steel tube and a large warhead on the end explains why such a simple weapon so quickly entered the practice of close combat against tanks.